All right. Mary, still okay? Cool. All right. So I was talking about LND.16, right? So you know LND is the name of the implementation, which you can use to run Lightning via your phone. You can have it in a server. And I guess looking at this talk now, it was kind of written for developers, but I'll provide more context as we go. We can ask questions about these things as well too. So .16 is going to be the release. I guess this is now like the 13th actual release of LND. So like major releases usually have like a bunch of big features compared to kind of minor releases, which we usually do bug fixes out. We're trying to like modify the way we do development generally as well. Cool. So let's go. A little overview. So first talk about kind of like ways we're doing to improve things on the protocol and the spec side. We call Roosing 2, which I'll explain. API type of thing. Kind of like Capri channels, basically a different way to make channels in the network that kind of increases privacy and can be lower cost. Watchtowers, which are this kind of defense mechanism. We just think we should improve that. Pathfinding, which is like a very important thing about Lightning in general. If you can't reach the other side, then it doesn't work, and it doesn't work, then that's obviously bad. Right? But we've been working on improving pathfinding with some new algorithms inspired by some other research in the space over the past few years. Some key changes, SQLite, basically this new database format, and I'll talk about some things we're doing beyond 0.17 as far as like how we're looking to improve going forward. Cool.
And we'll be also interested to know why you're in Israel. Like, how do you see like CTO integrated with Bitcoin?
Sure. Yeah, I can touch on that somewhat at the end. Yeah. And that was basically like talking about like me being here and true. But yeah. So one thing that is important for Lightning is basically kind of like propagating messages around the network itself, right? So for example, there's a bunch of like routers, and each router has like kind of like a policy, right? And that policy basically dictates if you route over me, you're going to pay the particular fee. So in the past we had some issues. There's just like a very long thing, one of the things where people were reporting a bug, I was like, is there actually a bug? We dug into it, we didn't really see a bug, but then people were reporting, okay, something must be actually there. So it turned out that we weren't actually properly prioritizing our own gossip messages, right? Meaning that even though like a user would say, okay, I'm updating my fee because now, I'm rebalanced, or I want to kind of like increase my cost because someone's undercutting or something like that, we weren't actually properly prioritizing our own gossip messages, right? So now we make sure we do a thing where we kind of like have this sort of like priority queue to make sure we're sending out our own message to other individuals, basically ensure that things are propagated a lot more quickly. And something like this, as soon as people start to update, they'll start to see, things, propagate a lot more quickly as well. One other thing that's really important here is, like, so we have something called, basically like Ellen scores, what people call the boss score colloquially, right? And one thing it's based off of is basically based on like node uptime, right? So say your node was down, or maybe like channel was disabled, basically. If your updates didn't propagate quickly enough, that would potentially penalize your score. So we realized, this is going to be potentially impactful because now people's scores should be higher because now they should be a lot more, reachable and available compared to how things were before. So that's a big deal. We also, fix some issues around kind of like dependency sorting. For example, like, imagine you get a channel update, and then you get the actual channel announcement itself, right? You may reject the channel update because you really never like the announcement. So we fix some issues there to make sure also that things will work properly, for those channels. Then cooperative close. So channels, basically, I can open a channel to you, right? And then I can also do a cooperative close. Basically means, okay, we're going to like just sign the multi-sig and then close it on chain, and there's no delay, right? The opposite is basically a forced close, where you basically say, okay, we're going to like just go on chain right now. Maybe you need to wait, potential days or weeks because you have like this thing called a revocation to basically ensure that like you're always moving forward in the state, and otherwise you're going to get punished, right? So this is like the happy path, and there's like a sad path, which I go more time. So with this, there's kind of like one of the things like I think in terms of like Bitcoin protocol, whenever you have like fees involved, things get very complicated, right? Even on-chain fees, as far as like booking the fee properly, doing fee estimation, people are kind of like stuffing a lot of data into the chain right now. Maybe we're seeing your fees go up. We'll see how long that lasts. So one thing that we expect was basically this thing called like a fee range, right? So whenever we want to close into this kind of like a negotiation, I would say, okay, I want to close at what type of byte? You say no, let's do 2. I say no, let's do 1.5. You say no, let's do 1.7. You can do that over and over, and maybe that's going to take a long time, right? So we have this new thing called the fee range, which basically says, okay, well, this is my lower and upper bound, and then using that, we can say, okay, well, I already know what's going to go on, so let's just kind of let's just cut things short and actually try to go this channel close channel a lot more quickly, right? And that's something we're going to implement it in .16. Another thing we're doing as well too is that one thing we realize that people always want co-op close to succeed, right? And it can actually fail in certain situations where okay, maybe I say your fee is too high the other way around. So we're doing something now. We're going to say okay, well, you should just always set whatever the initiator tells you, right? As long as it's within that that bound, basically maybe say okay, I at least want to get to the next, I want to get double, or maybe in the next block itself. We'll basically always accept whatever the other party offers to us, which is great because now we can also ensure that these things actually work properly. Another thing that we have is kind of like, set and forget co-op close, and that like now we'll kind of like have it to, such that you can just like hit co-op close, go offline, you as like the user or the receiver or the application whatever else, something is going to work properly, right? Before you would maybe try to close, and if there was an HTLC present, it would say, no, we can't do that right now. It was basically up to you just to always keep monitoring the channel to basically make sure you're not able to close the HTLCs there, right? But now we'll basically get that request and then just sit on it basically, and then wait until the channel is clear and then actually do the co-op close. So now the security should be a lot better because otherwise people had issues where they tried to close and then maybe it didn't really work and they have some script in the background, but now it should just work a lot better. So now if you do a close, it should close eventually, once the channel is clear, because we also do a thing where we basically stop running out of the channel, and then also now the feed should basically be what you expect it to be, because we have this better negotiation as well. And I don't know if anyone has any questions for this stuff, because this was written someone for a developer audience, and now I'm realizing this is a lot of there's a lot of context to it.
So I have a question.
Yeah.
So I have a question about the negotiation, about the co-op closing. So now my node try to co-op with other node and you get like a message, I will agree only to this fee.
Yeah.
So it's like one trial and error and not.
Oh, you mean like the new update that we made to it?
Yeah. So what was the change?
Yeah. So the new update is that before we start to negotiate, I had no idea what your preference was, right? Let's say I want 1 terabyte and you want 10 terabyte. I had no idea, so we'd go into like a very quick iteration basically of trying to actually make this thing work, and then maybe at some point we just bail out, right? But now whenever you connect to me, I at least know, okay, well he wants 2x more than I want. That's okay. That's within my range. So now you can basically cut things a lot shorter basically, and you also know if it's going to work ahead of time versus doing that and then getting the error at some other point. And the issue here is like, at the beginning of the spec we said, okay, people are going to negotiate what the fees are, but that wasn't very well defined at all, right? Like, what's your negotiation algorithm? Do you just never compromise? Do you always do what they do? Do you do like a 2x or something like that? So we're saying, okay, well that's very undefined, so let's just try to make it very, very simple. Okay, well, as long as it's within the range and it's not crazy fee, I'll accept it, so we can just move forward without having to do this very weird, undefined thing that can be unbounded as well. This could never finish. You could never do anything, and I never do anything, and then, nothing happens. So that's what we're trying to finish with this. Cool. Okay. All right. Moving forward. What was that? Oh, yeah. It's going to be retransmitted. So if you start to close and you restart again, then you're going to keep closing, and that's great. Cool. Next thing. So Moosig 2. I realize now this side has no details on this at all. But people are probably familiar with multi-sig on Bitcoin, right? You kind of have a 1 of 2 or 2 of 2 is like a threshold multi-sig thing. That's really cool, right? So one thing with that is let's say you add 50 keys, 50 or 50. That's going to be a very big transaction, right? A big transaction means you're going to pay more fees for that itself, right? And that's a difficult thing to do. So the other thing as well is that Bitcoin is based on this thing called ECDSA, which is like this other signature algorithm. It's kind of like an older algorithm, and it was kind of made in a way to get around patents at a certain point, right? But at a certain point, patent expires, so okay, we can use this new algorithm itself, right? So what this does, I can basically do a 50 or 50 multi-sig, but it looks like a single signature, which is really cool, right? So if you never imagine things like, something like BitGo or maybe an exchange hot or something like that, before that was distinguishable on chain. So okay, well, that's a 3 or 5, that's something else people are doing all the time, and then therefore I can recognize that maybe make you pay more fees for it. Music 2, instead, basically you can have several keys, and then add them up or aggregate them into one key, right? And then all 50 of us can have one signature for that one key, which is really cool. So one thing today with Lightning channels, the channels actually look like something different on chain, right? Because they're using a special scripting in Bitcoin itself because it has these multi-sig thing, right? But with this, we can actually have the channel look just like normal payments, which is really good for privacy, right? So now it's if I show you this transaction A, transaction B, and you ask me, is that going to be Lightning channel? It's kind of unknown, right? Because you don't necessarily know, because unless you actually know the keys or you're the individual, you don't really know it's going to be channel or not. The cool thing about this as well is that the co-op close now is a lot cheaper, because rather than having 50 signatures in the transaction, you only have one signature. So it's really cool because now you can have channels look more regular payments basically, and also you can have more advanced use cases be distinguished from regular use cases, which give you privacy and printability, and then also gives you some more flexibility the way you can do things in Taproot as well. This is something that people were working on for a while. There's something called Moosig 1.0, which is kind of the final version of the specification. So initially we shipped a version that was no doubt our prior version that wasn't fully finalized, you can say, right? But we did it so we can kind of experiment with it. We also wanted to use it for our product as well. So as you can see now, it's going to have Moosig 1.0 RC2, which is the latest version that just changed some ways you can add the signatures together that are slightly different, right? But the one thing is that we actually had things that are already deployed using this feature basically. It was using the old feature itself, right? And this is kind of like a difficult thing because we wanted to be, you could say, innovative and kind of push the envelope, making sure people have things are done. But at the same time, there's a new version out. We kind of take that risk on. So now there's a new version. That basically okay, well, you can use the old one or you can use the new one basically. And our stuff is using the old one for now. We're going to switch to the new one. There's also such that if you don't set this field, then you have an error, right? So it's kind of a way where we want to break it in a hard way versus do something that's silent. Maybe you have some invalid signature or something like that, right? And so we have these two products called Loop and Pool. Oh, yeah.
This is utilizing Schnorr?
Yeah, this uses Schnorr signatures, yeah, exactly. So Music 2 basically is a way to use Schnorr signatures to create a multi-signature that looks like a single signature, basically. And this is cool for Lightning because everything is a 2 of 2 signature by default. So all of a sudden now, rather than opt2 key check sig or check multi-sig, it's just now that single key, and also check multi-sig is now gone. But that's another detail. But yeah, it's something we're using in production. It's something called Loop and Pool. Loop is basically a way to move funds on and off the chain. So for example, imagine I had funds on Lightning, I want to pay you on chain. You can use Loop, or I can say, okay, I can top off my channel, and then Pool is something that basically lets you sort of buy and sell channels, right? Because in order to open a channel, that kind of opportunity cost. Maybe someone's going to pay you to do that because they're getting a service back and being able to receive funds. So maybe you can earn 3% something like that on your Bitcoin over time, and that's what we're using in that state. It's wrapped around this kind of nice session API because there's some kind of a bunch of low-level details as far as generating the nonces, finding the signatures, adding the keys, things like that as well too. We try to wrap that up in a simpler API to make it easier for people to use properly. And yeah, now it's just kind of a thing. And this is the thing that I talked about where 0 is undefined. 0 basically, if you don't set that, then it's going to complain. But then 1 is okay, boost O.4, which is the prior one. And then the second thing is this version 1.RT2. So ideally, these are going to go away over time, and then we'll only have the final boosting version of it itself. And this is important for the next thing we're going to talk about, which is tapping channels. But any questions out there? Yeah.
Hey, have you implemented Music 2 in Go?
Yeah.
Okay.
Yeah. I can talk to you about it. I'm going to help to audit that,
I'm doing that for the LibSecP one.
Okay, cool.
Yeah, second, have you looked into on the gossip channel, I'm not too deep in Lightning, but if I remember correctly, there are a lot of signatures going around there, and aggregating some of those using Music 2 or something like that.
Yeah, exactly. I'll talk about that a little bit later, but yeah, you're right. So right now we have 4 signatures in every single message, where it's basically one multi-sig key, the other multi-sig key, and the my key, and then your key, and the peer keys. So we can make that to one signature, and that's going to be pretty nice because then 4 versus 1 is pretty nice savings as well.
So does that mean if you're using Music now, it means that it will be harder to look and find channel opening?
Yeah. So right now you can say that Lightning kind of look a certain way because they're sending when the script hashes, maybe it's running leaves, and also once they're spent, you can see the 2 multi-sig and nothing else. So it's probably a channel. Maybe you just want to erase it as well too. So this would make it harder to track what are kind of unadvertised channels. So channels on my phone basically, right? This is really good because now you can't really do as much analysis or track the channels themselves, and also now the use case of that fancy Lightning looks the same as your regular payments as well. And now if you add things like coin join and things like that as well too, it gets harder to kind of track what's going on. And this is also cheaper as well too because now there's only 1 signature versus 2 signatures, and also there's some details around the script and things like that. But so you can say cheaper and then can blend in more, creating a bigger identity set over time.
Yeah, it gives the advantage of MPC.
Yeah, so before this you could use MPCs, there's multi-party computation to do with each DSA, but that was a lot more complicated. You do secret sharing, waivers and palliate, things like that. This is basically a lot simpler conceptually because you can just use the better structure of these signatures and stuff. So.
Yeah. Also, what about the RBF stuff? That also singles out the Lightning transactions, right? Because
the opt-in RBF?
Yeah, you do opt-in RBF. And
yes, so
yeah, there was the whole fiasco recently.
Yeah, with that, yeah. So this is for the funding transaction, basically. So the funding transaction, we don't do RBF at all because we just throw it out there and hope it confirms. And that kind of has improvement. But you are right for the commitment transaction as far as if I was going to force close, that does signal RBF right now. You can say other things that aren't signaling that, then that can stand out somewhat. But once you force close, because you need to reveal the script path anyway, then you're kind of
So only in false close did you use RBF?
Yes. So basically, we use RBF on the thing that spends the funding output, which is the thing that we're updating over time because we want to let that land on chain because if it doesn't get on chain in time, then you have issues with timelines basically.
Okay, so in co-op closing, there's no need for...
Yeah. No co-op, there's no need for RBF because we can just sign another one if you want to, or you can even do like a CPFP because, you know, if I have an output, you can just, you know, spend
both
that.
closing anyways reveals some sort of script.
Exactly. Yeah. So once you're forced, and particularly if you have HTLCs, you know, those look like something compared to another transaction, but it's like, you know, 1 in and like 50 out or something like that. So, yeah. Cool. All right, moving on. Taproot. So one other thing we're working on is basically, you know, incorporating Music 2 and Taproot into the channels themselves, right? So as I talked about before, channels are always like a 2-of-2 multi-sig, which is kind of like, you know, on-chain. You have list the keys and all the signatures as well too. Basically working on actually like, you know, upgrading this to use Taproot as well. So something I've been working on, you know, we call it protocol simple Taproot channels. And the other thing as well, there's something called the Bolt, which is basically based on Lightning technology, which is like the specification for Lightning. You can view it as like HTTP or like, you know, TCP or something like that. There's like a spec, there's RFC, there's something like that for Lightning, and there's one of the developers that work, you know, together, different companies to basically make that into a thing. So this is the proposal. So one other thing as well is that like, you know, Taproot kind of like gave you a lot of additional features, right? For example, you can do, you know, things around like the script path, and then, you know, even once we do things like PTLC, which is another way to do a payment reveal, basically. This is kind of very, very big design space. So we said, okay, well, that can take a long time. Let's do the simplest thing possible and ship that basically, and then iterate on that versus trying to do the big bang thing that maybe is going to take, you know, years, never show something like that. So this is basically like that simple version itself. And this basically, the stats are saying because there's lower co-op fees, it uses Music 2, that thing that you can aggregate the keys for the actual output, and then also now this is going to blend in with, you know, Taproot, or any of the Taproot chain. So we did do like a small amount of kind of like, you know, optimization on the scripts. For example, Taproot lets you kind of like, rather than having like one very big script with like an if else, basically you can kind of like separate that into like different leaves, and put that into like a Merkle tree, and then say, okay, I'm revealing the timeout path, or I'm revealing the delay path, basically. So we did do that, but we try to like restrict ourselves to just that because otherwise design space is very large. We didn't want to like, you know, get bogged down in a lot of those other features. So another thing with this is that like this is actually only going to be for unadvertised channels to begin with, which means, you know, on your mobile phone, between like, you know, like liquidity partners, something like that itself. Because as was mentioned a little bit earlier, you do need like changes for the gossip networks in order to actually get the Taproot stuff out there, because the outputs look different. So you need to know how to validate that to begin with. So we're working on that in the background as well. But this basically lets us kind of like, you know, decouple dependency on the protocol side, then just like ship this thing first, and then follow up with this later on. And we can actually have people do Taproot channels. One of the relevant thing here is too, one thing we're working on is basically the ability to kind of like upgrade your channel on the fly. Right, so for example, now there's like, you know, tens of thousands of Lightning channels, right? Imagine all have to close, you know, overnight to upgrade to this thing. Basically, you have to like, you know, close and then open a new one. That would be horrible. The, you know, fees would be high, would be backlogged. So we're working on basically a way where we can like upgrade these channels like on the fly, basically without actually closing our chain. So rather than like, you know, close and open, you basically hold an upgrade transaction off chain and then use that later on. So you still have two transactions, but you're kind of like deferring that to later, and then people can kind of like do it at their own will. This is really cool because, you know, once we upgrade people into this new version of Taproot, there's something else that would basically allow us to like have like better privacy in Lightning Network. Because there's something called onion routing, right? Where you can basically say, okay, well, you know, I'll have like an onion, and then I can kind of like encrypt it to other individuals, and they only know who's coming before and after. They don't necessarily know the entire route, right? With Lightning today, there's something called a payment hash, and that's the same along every single hop in the route. So therefore, if you're on two different spots in the route, you can say, okay, well, this is the same payment. So we're going to basically let you randomize that, but that's, you know, another thing entirely. But yeah, I think to validate this, you know, thing we call gossip 1.5. Yeah, mobile client, property liquidity. Yeah, this is going to be experimental because, you know, it could change. Or we like to, you know, ship things if we can, just kind of, you know, move things going forward. So it's going to be like an opt-in thing, and probably it's only going to be initially on mobile phone, things like that. But like I said, we are working on that like kind of like update protocol. So let's say things do change, you'll be able to update to the new version. You won't be stuck with the legacy channel because, you know, there's very big design space for this stuff. So we're going to make sure we're going to actually like update it on the fly versus trying to like, you know, do the magical, you know, version that's never going to happen because of byte shedding and things like that, blah blah blah, right? One other thing, this also is like a requirement to do something that we're calling, you know, TARO, which is basically a way to kind of like represent, you know, assets on Bitcoin. People, you know, things say like before, color coins, all these other blah blah blah. This is like our version of it, and we're excited about this because this will let you kind of like, you know, have other assets or stablecoins or whatever else, you know, on Lightning as the edge. So basically, imagine like I have a phone and I have like, you know, this like USD stablecoin, right? I can actually use that to send Bitcoin to money, right? Because the first hop it changes from USD stablecoin to Bitcoin itself, and then goes across the network in Bitcoin. And at the end, they can get Bitcoin or they can get anything else they want, right? So this is really cool because now like, you can say Bitcoin serves as sort of like, you know, backbone network for any currency in the world, right? So rather than like them going through these other networks, you can say, okay, well, I can plug into Lightning Network itself, it transfers over Bitcoin. And the cool thing about the way we're doing this right now is like it's fully operating, right? So let's say I had a node, I wouldn't even know that this was like a transaction that originated, you know, from some other, you know, kind of asset or something, right? So I can just use my node, and, you know, I didn't basically like, you know, has more volume than Lightning itself, which means more growth, means more payments, which means kind of like a flywheel of more activity as well too. And this is like Taproot channels is kind of like a prerequisite for doing something like this in the first place. And there's something, we're working on another specification to basically describe how this thing works. And once again, everything's open. It's an open protocol, right? So anyone can also implement, their own client from the ground up. They can also tap into the ground up as well too. And because it opens up, we can also get feedback from other developers because maybe we didn't get it right the first time, right? And maybe we can improve on that and kind of help us iterate and kind of analyze these things in detail. Cool.
So Lalu, the first iteration will be compatible with LDK. Like, is there a buy-in from other implementations as well to the chapter channel?
Yeah, good question. So far, LDKs, they're the ones that seem to be most ready as far as kind of they have some chapter tools already and they have BDK things like that.
And the specification is the same, that you're working on.
Yeah. So we're working in tandem with it. Basically, I'm working with some of the developers, alongside this, and we don't really want to ship this until we get some initial interop, right? Because then it's just kind of we don't want to be seen like we're doing our own thing type of thing, right? So I think the others will come around eventually. I think there's just a lot of things on the protocol side, and I think also for example, that thing I talked about music too, that's not yet in libsec P, which is the library, the C library everyone else uses, right? So I think he's talking about he's helping me review that. So once that's there, then they can catch up. But also at the same time, people need to update their wallets to understand Taproot, right?
So CLN are waiting for.
Yeah, exactly. So CLN and Clear, I think they're waiting for that, but I think also they haven't yet. I'm not sure if they can generate Taproot addresses, for example, right? So I don't know if their wallet supports that yet. So that's something we did a little bit earlier on. But once they have everything else in place, they can have it with us. But at least we can make sure we're working with another implementation, have an interop going forward, and then they can come through because there's a lot of spec proposals in flight right now, and maybe they're focusing on some of those for now. Cool. All right, watchtowers. I think I actually had a little intro here. Maybe I didn't. Okay, with the way Lightning works, there's because channels are off-chain, you can say there's no final version of the state, right? So imagine, let's say, we're doing payment back and forth. Let's say, okay, well, I have 10 now, but I had 20 in the past. I want to go back and broadcast when I had 20 because it's better for me, right? And that's going to be a big issue because otherwise, I could always kind of cheat somebody and then always make money on a channel, right? Because it's fully off-chain, right? Every time we do a payment, we're not actually going on-chain. We're kind of holding this stuff off-chain. It's kind of like a spend of the multisig itself, right? So there's something in Lightning that you basically have a delay, right? So whenever you want to go on-chain, there's kind of a delay to let me say, okay, well, no, he cheated. It's kind of so I went to court and I had some time to basically refute what you did in the past, right? But the thing is, there's a time factor there, right? So maybe I need to be online every day, every 2 weeks or something like that, right? So Watchtower created a place to basically let them watch the chain on your behalf, basically, in a trust-minimized manner. Where if someone cheats, then they can say, okay, well, you cheated. I have a signature that was from the other individual, and basically shows you cheated, and you get all the money, basically, right? And this is really cool because now you can kind of sort of outsource this vigilance to another third party. I can have it on my phone, everything's okay because I don't really need to be running this all out the entire time. You say right now we have 2 different ways to do it, and this is built into LND. When it's altruistic, so maybe this is my own tower, or maybe it's my own company, where I just do it and I don't get any money here. That's fine, right? Then we have another way, this reward mechanism. This is okay. Well, if you do catch the cheater, you can get 10% of the funds in the entire channel because I was already made whole at that point, right? And people are working on other ways to basically allow you to sort of maybe pay per state. Because you can imagine, every single time I update something, it's actually it's going to take up some disk space in the other individual's computer, so I can kind of have them pay over time. It's also going to be a new way for someone to earn money as well. Cool. One thing is over time, when you have a tower maybe around for several years at this point, Lightning's been operating for several years as well too. The disk space starts to fill up over time, right? And something that we want to do is basically in this release is really optimize the disk space reduction, make sure things aren't taking over so much space on disk itself. So we have some different ways to do more intelligent indexes. We use things like parts as well too. And I think someone ran. I think they have a 4x space reduction, which is pretty good. That someone went from 16 gigs to 4 gigs, and we can even do more stuff beyond that. There's a bunch of other things we want to do, but we wanted to make sure we can actually ship this stuff first, reduce the scope, and then keep moving forward. Other thing, we also reduced memory because we had an issue where if a tower wasn't online, you basically would build up all these updates in memory basically, and you would just consume gigabytes of memory over time. Now we have a way where we can say, okay, well, rather than always keep these in memory, we can kind of have a more durable queue on disk, and then check that when they're online to actually make sure things work properly. And we also fixed an issue where in the past, if you had a tower and they went away, you couldn't remove that tower. It would basically complain to you. But also, if the tower is even online, you couldn't remove that. You couldn't update it as well because it's some very, very old bugs in the system. But we fixed that as well too. So generally now towers, you can say they're going to be a lot leaner, less disk space, less memory. But then also now we fix some issues to basically let you make sure you can migrate a tower because maybe this is a different business, or maybe this is you're another computer as well.
I'm not very technical, but I want to ask why should you keep the list of states over so much time, so many years? Why won't the two parties decide?
So
to just like yes.
Yeah, so that's possible as well. So you can say like, if we had a channel for years, we can then close and then reopen the channel and we can forget all the past state, right? Mm-hmm. So we can sort of like, just say, okay, we're going to start from new, forget what happened in the past, we have a new state. So you can do that to reclaim the state. But also like there's some ways where, you can store less data basically. You need to store some data per state, but then there's ways you can sort of, put things in a tree, compress it down so you only store like a logarithmic amount of data compared to the number of states basically. But you are right that like if we wanted to say, okay, well, let's just start from scratch, we can close and reopen, but that's an on-chain transaction. And in the past, back in the day, fees were high for a while. Now, you guys are spoiled. It's like once every black year that's changing. So that was like a little bit less attractive.
Cheap. People use it to
they're stuffing the chain.
JPEGs on the chain.
They're uploading their backups in blockchain, right? So it's not gonna last. We'll see. Cool. Talk about adding movement. All right, pathfinding. One thing that's very important in Lightning is basically pathfinding, right? And the way Lightning works, you can say that like in addition to like actually finding a path itself, every single channel also has a balance, right? Which means that like in addition to like actually doing the pathfinding itself, you need to either try to like optimize like a sort of like flow to another individual, or maybe try to estimate based on some prior observances, is it going to work or not? For example, like let's say the channel has 1 BTC and I send 70 satoshis over and that works. Okay, maybe I can send 80. Right, but let's say 90 fails. Okay, maybe I know now I shouldn't try to set 90, right? So we've been developing algorithms over time to basically allow you to sort of like estimate the probability of success of a payment, but then also based on your past observances as well too, right? And so you can say, okay, well now it's kind of like a Bayesian probability thing. Given the amount is 5 BTC and it worked last time, will it work now type of thing, right? And we've been working on optimizing that over time. One issue that we had in the past, because like once again, we shipped something that we knew worked, and we're going to optimize a little later on, is that the probability estimator didn't actually take into account the capacity of a channel, right? So let's say you're sending like 1K Satoshi over a 200K Satoshi channel. That would basically be the same probability as sending 1K Satoshi over like a 5K Satoshi channel, right? In one case, you can say, okay, well, I'm sending almost 25% of the capacity, so therefore I should have like a lower probability of actually succeeding. So this is something that we did now. It's going to be there by default. So this actually should be really great. It should be really good for like larger payments. Should have like a much better success now, because now we won't try to like send 90% of the payment over. We won't try to utilize something like 90% of the capacity of a channel. We'll say, okay, well, let's actually split that thing up. And also, Lightning, you can actually split up payments. So rather than like doing it in one flow, I can say, okay, well, I'm going to split it to 5 different payments and then use that as well too. And this is going to be a big deal. So this is like an example of like the probability of success of kind of like sending from like 0 or 1 Satoshi all the way to the capacity of a channel. Before, this would basically be flat. You would say, okay, well, I can send up to 0.9 BTC of a 1 BTC channel, which is realistic because you can say because of the way things work, maybe the funds will be on the right place at the right side. And this is kind of like the algorithm that we use right now in order to create this kind of like curve. There's some parameters in here that we can tune over time, as well. Yeah, and one other thing that we made sure that like if you do this naively, this means that you only favor very, very large channel, right? Because you say, okay, well, the bigger the capacity, the better the channel, right? So we made sure as well that like small channels are still kind of considered accordingly to make sure we don't always go for like the mega nodes, right? We want to still make sure that we can do payment splitting properly as well, and we did a bunch of tuning on this, and I think it's going to be pretty big improvement.
That's a variation of the P-card payment, or like it's the same? It looks the same.
Good question. So this doesn't do like min-cost flow. So this doesn't try to do like the fully optimized path of itself, but it does use kind of like some of the terms they developed just to like estimate the probability, right? So this is one of them. To do this, basically kind of like, okay, well, you're going to drop it off based on the actual capacity, but then we did some additional, tweaks on top of that to like make sure there aren't degenerate cases. We're not doing the optimal thing. We're still doing our media algorithm today. So,
what's your take on the min cost flow?
I think it's something that we definitely identified early on. It's like the proper way to do it in terms of like the actual algorithm problem itself. I think it's one of those things where it's like sometimes like just good enough is okay. And so I think if you're doing something where it needs to work in a very, very large payment, maybe it makes sense to do that. But I think the other thing is, well, like it does add more complexity to the algorithm because you're doing all this kind of like solving. You basically have this optimizer and things like that as well. And the optimizer also takes CPU to do the solving. So I think people will go toward it eventually, but we're trying to like at least take the bits that we can to incorporate it rather than like spend a bunch of time to do this rewrite and maybe like it's not as good, blah blah blah. So it's kind of an iterative thing that we want to move towards.
This actually affects even nodes that are connected to only one other node because the whole path is calculated. So even if I must go through the
from my only channel, the whole path is
the MPPs are split on the source side.
Yeah, and then this is applied, you can say, for like every hop, right? So we basically compute the probability for every single hop, then we can multiply that because, they all must work together in order to get the human across, right? So this is something, this is going to be like, so this was an update to the default algorithm that we have now. So generally payments should just be better, and particularly for like larger payments, and there should be less attempts because now like we should fail less, which means we don't need to like, reiterate and then split and then maybe have some general cases. We have a bunch of other ways to think on this still. Okay, this one, all right.
What's the, can you please tell what the OS stands for in the third item? Probably OS reduced accordingly.
Probably, that's a typo. Probably is reduced accordingly, right? So then we also developed a new algorithm, right? So one thing with some of these like prior models, because it can make the math nice. Sometimes they assume kind of like a uniform distribution, right? Which means all the funds in every single channel of the network basically, or basically just kind of like where you'd expect them to be if you kind of like flip the coin and have this sort of like random thing going over time, right?
Yes, Lalu, is that an opt-in algorithm? The previous.
So the previous one is on by default, but there are ways you can set the config to disable it.
I'm just worried to break our custom MPP implementation.
Good question. I'm pretty sure we set the config so that you can basically disable this, and that would get a test as well, and we'll definitely something to visit in the RC phase, like the race candidate phase.
I see the probability starts at 1 and it doesn't end at 0 because you can pass a million satoshis. Am I right? Pass a million satoshis at probability 10%, maybe 5%.
Yeah. I mean, we'll get to. I think this is just like an artifact of like Wolfram Alpha, just kind of like just now rendering the asymptote there. So
okay.
I think we'll get to 0 when you try it.
When you go to million one.
Yeah, if you do million one, it should be 0, right? Yeah, like it should just say I can't do that, and and at that point you wouldn't even get to this estimate because you would say I can't do that payment at all. Yeah. Cool. So this is like another thing that we're working on. Basically, so what I'm saying, like, already the algorithms assume sort of like that things are kind of like equally distributed across the channel, right? And every single channel is just kind of like in this sort of like magical limbo state, right? But then we started towards experiments, and like I think this also kind of like matches the empirical observation that like most channels are kind of like actually on like one side of the other, right? It's either balance on my side or balance on your side, and that's also because like channels typically are unidirectional. So I open the funds, it's all on your side. Maybe until we do a rebalance, something like that. I think also it's the case where like many flows in the network are asymmetric, right? Some people are sending more than receiving. It's so you have like a 50-50 balance between everything else. So this is meant to kind of like sort of reflect the kind of like the reality of the network itself, right? So we took this and then we kind of like derived another like weight function, which is the one I showed a little bit earlier. That basically it takes into account that like things are actually on one side or the other, so therefore I should update my my estimates accordingly, right? And I mentioned earlier, so this is like the new version. This can be toggled dynamically, really good thing. So you can turn it on, try it. If it sucks, you can turn it back off. We want to make sure we're not like forcing people into one particular instance of it itself, right? And one other thing, as far as like the way the prior one worked is that like because you assume uniform distribution, you sort of assume that like even if you're standing up a very very high number, using like very high capacity channel, it's still going to work, right? So this is saying, okay, well even if you're doing 90%, it's still going to work as well as if you did 70%, right? But this one says, okay, well because funds are on one side or the other, I'm probably not going to be able to send 75% of the channel in one go, right? So it's a little bit more pessimistic per se, right? The other thing is with the algorithm. The other algorithm would basically try to like fully maximize the flow of the channel. So if it thought it had 0.7 capacity available, it would try to use that entire capacity. This one's a little bit more pessimistic. It's like, well, I'm going to use 25% here, 30% here. So there's kind of like a trade-off there that we think can work a little better. But as you're saying, this isn't going to be the default yet because we want to say, okay, well, it's actually going to work properly or not. This is kind of like the difference between the two. Like we're saying, this one says, okay, well, it's hard to send more than 80% of the channel because things are unbalanced. While this blue one is basically the old one that was okay, well, we can continue to send as much as we want to, basically. And then this graph's a little bit hard to explain. I have to like review it every time. But so in this graph, like the red amount is basically like trying to send the entire amount, while the blue is basically trying to send like a very small amount, right? And what you say from this is that like basically once you start to try to send like a larger amount, basically the probability should more or less be 50-50, right? Rather than saying I'm sending 0.7, I'm going to send more. This is basically like says, okay, well if you're sending a smaller amount, that's fine. We can say it's probably going to work. But once you get to the larger side, we're going to back off or maybe split a little bit earlier to prevent something like that from happening in like a general case. And this is the uniform algorithm basically. And with the uniform algorithm, you see even if you're trying to send a very large amount, you still end up assuming it's going to like work over time, basically, right? And this basically makes it more greedy because it's going to try to like actually try to consume more capacity. But at a high level, you can say that like this one tries to be more pessimistic and rely on the fact that channels are mostly unbalanced in the network itself, and will also not try to consume as much of a channel as possible, right? So you can say like maybe this one is sort of like more globally kind, because it's trying to take only just what it needs versus trying to like take everything, the entire capacity. We're sort of experimenting. We have a bunch of like things we're going to work on once this is done.
Like the more purple colors are closer to uniform, right?
So this one is the bimodal one. This one is the uniform one. So like red basically means trying to send more funds over the channel. And then blue is basically trying to send less funds. So the contrast is that like if you look at this one, at a certain point, when you start sending more, it's like, okay, well, it's going to be a 50-50, right? This one is saying, even once I'm sending most of the channel, is it still going to be 80% probability? So this one is going to try to consume as much as possible, while this one will say, hey, I don't know what's happening after this, let me just back off, because you can still split the payment. You don't have to take it all in one go, so you can split the payment and then try another channel basically, and then take that into account. So, cool. SQLite.
How do you guys are testing this stuff? Like, are you testing it on the real network?
Good question. So, like, we initially arrived at this, kind of model based on like, the observations of like, just like looking at some probing and things like that, right? So right now, we've done some testing just in kind of based on like, just things.
With MTP? How do you
So we're developing a sort of like virtual like texting bed network, right? So basically imagine that like, using some like HLC interceptor, you basically send out a payment, and then this thing tells you if it's succeeded or not, right? So therefore we can kind of like, create like a canned virtual network with topology and see how this is functioning over time. And it's also generic because we can then connect any implementation to this thing, right? Because we can connect C-Line and send the payment, and then we say something happened, and then we fail back itself, right? So they can actually be used to sort of like have a more dynamic benchmark system across the network itself. Because otherwise, like, it's easy to write like a test that tells you what you want to test, basically, right? So, but we're trying to say, can we like, have more dynamic topologies basically we're working on? It's not quite finished, so we hope to open source it eventually. And one of the things that we can do for this too, we can also do like A/B testing on something like Loop, right? So, okay, well, some clients we can opt into, we'll give them the older one, we can do parameters also, so we can actually get some more real traffic because the real network is, it's dynamic.
A/B testing on the real network.
Yeah, exactly.
Can you explain how such observations are possible? I guess not any NNV node just send that data away to everyone.
Yeah, exactly. So like that was based on like, our own observations basically, because you can try payments in there basically and see if they work. You can also make a payment such that even if it gets to the end destination, so they still fail it back.
So you're like launching like thousands of nodes and see the logs from the...
Yeah, exactly. So you can do that, but also like, we have services where users over time are actually sending payments continuously to us. So we can even say, okay, well, their probability of success was 80%. If they do algorithm B, it's 90%. So we can do kind of like A/B testing in the wild to try to choose some of these algorithms as well. But you are right that like, it's not easy because like, the network is always dynamic basically. And you always need to be updating your algorithms and everything according to like what's happening on the network itself. Cool. So we have a new database version. So we have something called Bolt today, and I wrote this stuff a very long time ago, and it worked then, right? It was great. Something called etcd, which is used in Kubernetes. I was like, okay, well, the big board is using this thing. It's gonna be great. I use instead it has some cool, concurrency control, but it actually had, some issues, right? So one thing is that there's kind of like a trade-off between like performance and startup time. It's something called like a free list, which basically like keeps track of like what has been written in the database, right? And things like if you sync this thing, then the writes are very, very slow because it basically needs to sort this entire thing every time it's writing into this. But if you don't sync it, then upon start, basically needs to reconstruct the entire free list, right? And this can take minutes, even an hour for like, very, very large nodes, right? And people that went out with you, they know the pain. And the other thing as well is that, performance starts to be made for very large databases as well because the free list gets very, very large and gets fragmented as well too. So there's something called compaction, which basically lets you, kind of like, sort of defrag the free list itself. But compaction is just inserting the database into another database, right? So that's actually taking a bunch of I/O this entire time, and this is why at times both compaction and sharding can take a long time. So instead, we're looking to add SQLite, which is basically like an embedded, SQL, database. It's used around the world, so it's really popular now. Like in the past 2 years, it's like the new hot thing on Hacker News. Like every week, there's like a SQLite post for some reason. And one thing we want to do is we basically want to kind of like modify LND to start to actually use like proper SQL tables, right? So we have SQLite, but we're actually just using it as a key value store. We have like one big table with a key value because like it was very simple because we don't want to like have this very large migration which would maybe take a long time. We have a lot to say whatever else. So we just did that. We said, okay, well, you can use SQLite. We also support Postgres as well too. but now that we have like SQLite and Postgres, we can say, okay, well, both people, it's kind of like maybe like a second-class system. We can start to optimize the data store and to actually, use proper SQLs together, which is great because, right now, in order for us to exploit anything on the RPC layer, we basically need to maybe add new index, a bunch of new calls, basically include this data, right? So versus them reading directly into the table and do, select all invoices from blah blah blah, join where payment hash blah blah. So you can do that now, which is going to be a lot better, particularly for the large nodes as well.
So you're saying the SQLite will work also with Postgres and.
Yes. So today,
if I'm running the node, I will be able to connect it to my own database.
Yeah, exactly. So today, if you're running Postgres, because you're building something else, you can connect LND to Postgres itself, right? But it's pretty slow because it's using Postgres as a key value store. It's not doing joins. There's no query optimization. There's no, any all the great things you can do, altruistic recursive things like that itself. But this is going to let us sort of abstract things to one higher level because now we're not purely in key value land. We can then also do proper SQL schemes and things like that as well too. So that's something pretty excited about. And the other thing too is right now only one process can read bolt at a time. But SQLite has ways you can kind of do proper locking, you have multi-process scaling on it, and then also things like Postgres. Once you actually use those features, you can scale a lot better than today. And obviously the big thing there is also you can get proper replicated data store, right? Versus today having everything on one database and then maybe using some kind of maybe block level replication, you can then kind of have a proper DB.
So for key value stores, there is any way to use Redis?
That's possible as well. I think the main issue is that we ended up sort of having to write our own indexes, right? Which can be very for developers and hard to review. And then also if we were to do something okay, let's get all of the invoices before a certain date. We either need an index or we just scan the entire thing, right? And then just say, okay, we're picking these things over time versus doing select, where blah blah blah, and then having that be optimized as well and things like that. So. Cool.
Yeah. I would just know that Bitcoin Core's new wallet also uses SQLite now.
Oh, cool. Yeah, that's pretty good. And to be honest, the reason why I used Bolt in the past is that I just didn't know SQL. It's kind of because I'm making this thing. It's early on. We need to iterate very, very quickly. Key value store. Okay, this is good. It's also back when NoSQL was a thing. Big table, things like that as well was a trendy thing. I don't need SQL. I'm just gonna write my own shit, right? And that's what I did, right? But now, in the past year, I'm I can write queries now that before would have been intimidating, right? And we also have pretty good tooling because so rather than some of the projects rather than use an ORL, which maybe can hide some details, we have something where we basically write SQL and then that generates Go code that we can write and interact with the regular code, but then we also have the queries so we can actually go into the database and use things like that as well. So I think we have a pretty nice tooling, and I think big businesses are really going to love this thing because now they can just hook it into Amazon RDS or something like that, or anything managed Postgres instance as well. And the SQLite has some pretty cool features as well. For example, it has things you can do JSON queries. It has rich text search. Has a bunch of really cool features alongside too. Cool. Last slide.
But we're not there yet in terms of having multiple nodes running against the same.
Good question. So that'll be a .17 thing, right? So today you can have that the failover thing,
yeah.
But if it's on a single database, it's not that great. But then also if it's on etcd or Postgres with just the key value, it's still not that great as well too. But then there'll be an option where you can use etcd to basically have leader election, but then Postgres is handling all the streaming replication between other instances as well. So then it would be a lot better. Okay. Yeah. Cool. Final slide. There's some other stuff that we're working on. SQL. So right now we have we have things in SQL, but once it gets only key value store, we're basically working on adding better schemas basically for basically one of the most heavily iterated things, which are invoices, payments, forwarding, packet channel sync, because people have millions of invoices now, and this is something that really starting to bug out their node. And the other thing is, well, I mentioned before, we were working on accounts just a while back. In order to actually fix what you have in accounts, we had to add utility new RPCs. But now you basically just hit the stuff directly to have that itself. We want to do things split out the gossip handling from the LNG itself, because right now it's all in one process. And you can say, okay, well, I can do my channel with this process. I can do gossip handling with this process. It would be really nice. Something called gossip 1.5, which basically is a way to let these channels be advertised in the network itself. Blinded paths, which is a way to sort of add more privacy in the network by obfuscating the final hop, right? Versus today, or whenever you're sending a payment, I know I'm going to Bob because Bob gives me his public key, and I can direct to Bob, and I can basically go to Rodrigo, and then Rodrigo maybe gets over to Bob. It's kind of like a rendezvous round type. I think people are familiar with Tor. Inbound fees, which is basically a way to let you control kind of your liquidity flow. So, you know, the one thing on Lightning is that like things get announced over time, and like there's certain people that basically do arbitrage, right? They sort of like route one way, then route another, and they can actually make money like that, right? Or they can make you, you know, spend money. There's kind of like a, you know, this like game going on basically, right? So inbound fees basically let you make it more expensive or cheap for people to go in a particular direction, right? So let's say I had a channel that's like depleted. I say, okay, hey, if you route through me to this channel, it's going to be cheaper than going to another channel. So this basically gives you more control of your liquidity, and something else, you know, called you know, dual funding, which is basically a way to like create a channel, but you get people put, you know, two people basically put funds in the channel at the same time as well too. And then these are working on some of them are being worked on by ourselves, some of them are being worked on by contributors as well, because you know, it's an open source project. We want to get more people you know, working on the code base. Cool. That's everything. Question.
Won't the last two items also complicate highly the algorithm for efficient...
For pathfinding?
Yes.
Good question. Yeah, so, you know, there's kind of like an issue where if you have inbound fees, but the fee can actually be probably negative, then you kind of like have these issues of like cycles, and like certain algorithms don't handle it, certain algorithms do handle it as well too. But the version that we're doing won't be negative fees. It'll basically be a discount, right? So it's like if you route to me via this channel, the fee that you pay when you route outbound will be cheaper than otherwise. So that's the current implementation. You're all right that like if you make it properly negative, you need to switch an algorithm, because things like, you know, Dijkstra's algorithm can't really handle that. There are ways that you can, you know, limit the cycles, things like that, but we're not trying to take the full step forward. We're just taking the initial step of like letting you do the discount, and then later on you can do negative fees, which is like something that people were talking about very early on as far as like, you know, paying people to run in a particular direction, but that, you know, gets complicated as you're saying, and has some other interactions going on with it.
Where are we with onion messages or bulk will?
Yeah, good question. So I think the current plan is for us to do the blind paths first, because everything else relies on that, right? And then, you know, we're also working on basically doing the forwarding, because even if we don't do bulk 12 or like the onion messaging yet, people can at least use L&D node to basically do the blind path itself, right? Because blind paths needs updates in the core of the network to basically do the new kind of like packet processing itself. Right?
I'm just getting at the like async payments. That's what I want to do.
Yeah. I mean, so we're working on it. It's just, you know, working on it in bits basically. So I think the idea is basically
and
first.
And the one that Carl is doing, like.
Yeah, exactly. Yeah. So this relates that, and we have some other people working on it now as well. But the idea is like at least if we can like send the blinded payment and then also do the forwarding, then people can be doing it all around us. Then also like you can even have like a type of bridge that like, you know, supports the other protocol basically, and then, you know, inject it to LND. Okay, hey, this is a blinded path payment symbol to like send, you know, to route or something like that, right? So then at least like we're saying, okay, well, you can do it at the core of the network, even if things are a little bit slower on the site. And I think the other thing is, well, like, you know, when we're doing the invoice rework for the SQL schema, basically, we can make sure we can support future formats in the future, like the different bulk 12 encoding or the offers, things like that as well. Because otherwise, right now, like things weren't that great. They're pretty inflexible with the way the invoices work today. But as we do the SQL thing, that'll make things like bulk 12 and things like that easier to manage.
And did you arrive to a consensus regarding messages? Like, what's the status there, like from your standpoint?
Good question. I would say not necessarily. I know people have like interop things like that, and I'm pretty sure like, you know, one of Carlos things has an interop with the other thing as well. Too, I still think there's some questions around like some, you know, DOS stuff. Yeah, like think about Nostr, like we were talking about just now, right? So, but at the same time, like, you know, there are other things we're working on to like the upfront fees, things, blah blah blah, things like that as well too. So maybe that can be combined alongside of it to basically like have that payment thing if you need it, and then otherwise it just works. There's also ways you can do kind of like rate limiting that rather than like actually make monetary, you can have a proper rate limiting, things like that. But like I still think like we need to develop that stuff more, because I think the worst case is we do it and then it doesn't really work. People can turn it off. Maybe that's gonna be like a bad thing. Maybe we get like overloaded. But at least like I think there are those methods that we can use to do rate limiting either for payments or like based on bandwidth or delay. It's just a matter of kind of like actually, you know, tuning that stuff out. So, but I think people, you know, obviously they need to deploy it first, and then they can do the tuning. So I think we're at least making sure things can be deployed with blind paths and so forth, and then they can do the tuning afterwards as well too. But you know, yeah, that's kind of the same thing. So. And that's the last slide. So, yeah.
Can you tell about the deployment process of a new LMD version? So how long does it take for a certain percent of the network to adopt it?
Good question. So it usually is done over time, unless we have a bad bug. Like what we had last year, like no fucking update right now. Like usually, you know, probably takes. I think it depends on like if there's compelling features or not. Right? Because, you know, if you're on a version that's stable and that's fine, that's cool. But if you want to do path tracking algorithm or you want to use tappers, then people maybe incentivize you to upgrade. But, you know, probably like a few months, I would say. It's not like an instantaneous thing, and then people can run older versions because, you know, it has whatever they need. So, probably takes I think 6+ months to get like pretty good penetration. But now people run Umbrel and maybe you can do like a button to update.
I think it's really complicated with the routing stuff because when most of the network uses all the implementation to have like a better algorithm, it might be only better if a certain % of the network is using this algorithm.
Yeah, I mean, so for example, something like blended paths, like, in order to do it, the entire path needs to be upgraded, right? And that can take some time, basically, right? And until the entire path is updated, you can't actually use it. So, things in the internal network can take time to update, but like, there are certain things, for example, like you can have like a new payment type, and sometimes you only need the sender and the receiver to update, right? For example, something like the type of channel that I talked about just now, you only need one party to update, right? So it's kind of like similar to the internet, right? It's like something called an protocol. Okay, well, certain things take a very long time. You have to change driver calls, but if you're doing, some new UDP-based protocol, UDP's already deployed in the network. We could just like do something slightly differently, right? So we typically look at, kind of like the upgrade path for bigger things like that. And for example, some things I talked about around kind of like PlebTLC, which basically let you improve privacy in the network and do things like routing DLCs, things like that as well, which is basically a way to do like contingent payment. That can take a little bit longer as well. But I think something we really want to plan out now to make sure we can kind of like have like a sort of upgrade kind of in the future to make sure we can reach that point. Cool. Any other questions? Yeah.
About the bug, what would happen if many people find out about some danger, some bug, and try to close all the channels together? And we see this now with the NFTs that they are clogging all the blocks, and because everything depends on time locks, you have to close your channels on time.
No, good question. Like the critical thing there is basically like feed bumping, right? So like those channels have in the past where if you like tried to force close to the ones that you need to go on the chain very quickly, you couldn't actually do a feed bump, right? So therefore you basically have to guess what the feed rate should be ahead of time, right? And that's fine, but maybe if you're offline, maybe there's a big spike, you were potentially in like a bad position, right? Then we had something called like anchor outputs, which basically let you do child pace for parent, which is sort of like spin transactions increasing for the entire thing, right? So we have that by default, and that's kind of like the default channel type. So now like as long as you're in the mempool, you can then still bump your fee over time. And so we have something that does some automatic feed bumping. People can also do manual feed bumping as well. But the one issue with that still is that like some nodes kind of like have like a limit on the mempool size, right? Which is maybe 30 megabytes, right? So let's say like things are getting very big. If you fall out of the mempool, then you don't even know what's happening, and you can't do a feed bump because it's using CTMP. You need to reference that at the prior transaction itself, right? And people are working on like things that let you sort of like propagate set transactions together. They call it package relay. So okay, well, this thing has 0 fees, this thing has 27 byte, and we're going to do that itself. So like until that's like fully there is still that zone of which you can fall out. So what we do, we basically do like a very sort of a conservative estimate on like the fee rate before we broadcast, but then we can also do fee bumping after the fact as well too. We're also working on ways to sort of like have a sort of like algorithm to like kind of plot over time what the fee should be based on the delay as well. So fee bumping is basically the main thing, and I think one of the most difficult things for stuff like this is just like handling fees, both on chain and off chain as well too. Because if you can't get in the block, then that's bad. If you can't bump your fee, that's bad. And if you're paying too much fees online or throughout, that's bad as well too. So fees are something that like we've been working on for a while, and it's like one of the hardest parts of like dealing with Bitcoin itself, you can say. So yeah.
Sounds like someone should fund Gloria.
yeah. She's definitely doing good work on this. She's working on
Gloria is she's working on package relay on Bitcoin Core.
Yeah. Cool. All right. Nice. Yeah.